David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Why was the math book so sad? Because it had too many problems. Okay, today's topic, finding equations for lines. And we're going to go over 3 different techniques. I'm going to outline them real quickly right there and then we'll dig in. So, first technique, if you have the gradient or the slope and the y-intercept, then you can come up with the gradient-intercept form of that line equation pretty quickly. Secondly, you might not have this, but you might have the gradient and one point. So that's another way you can create the equation for a line. And then lastly, if you have one intercept and one other point, you can also create the equation for that line. Okay, this technique is probably the simplest of the 3. This is if you have the gradient and the y-intercept. This is just a plug-in. You don't need to do any computations. We know the general form for gradient-intercept is y equals mx plus b, where m is the gradient and b is the y-intercept. So let's take a look at what we have. Y equals, now we know what m is. M is the gradient, so that's 3x. Now b is the y-intercept. Check it out. This line passes through the point 0, negative 2. That is the y-intercept. X equals 0 at the y-intercept. So the number for the y-intercept is just minus 2, so you just throw that right on there, and you are done. So this is a plug-in process to get that line equation. Okay, the second technique is, again, when you have a point and the gradient. So we do have the gradient again, but now we have a point that, check it out, it's not an intercept. So we can't quite use technique 1, but this technique will help us do it. So we have gradient, it's 2/3, and it passes through the point 3, 1. So what we do is we use the point that we know and the gradient to do a plug-in step, and then we can solve for the intercept. So step 1 is plug in and solve for C. Solve for B. So remember, I'm going to start with our slope-intercept, our gradient-intercept form. Y equals mx plus b. That's the general form. Now we're going to do some plugging in. So x and y, this point, this combination of x and y satisfies this equation. So we're going to exploit that. Here's the y. That's the 1 on our point. So 1 equals gradient. That's 2/3. 2/3 times the x value. We know what the x value is. That's 3. 2/3 times 3 plus b. We don't know our y-intercept, but now we have an equation that has just one variable and we can solve that one. Bring down the 1 equals 2/3 times 3 is just 2 plus b. Subtract the 2 from each side. Minus 2 minus 2. We get minus 1 equals b. So now we know that the intercept for this line is negative 1. So the second step here, I'm going to squeeze it in over there, is plug intercept in. So now I have y equals, here's my slope, 2/3. I'm going to go back to just showing x and then minus 1 for my intercept. Like that. Okay, I would like you to pause the video right now and try this problem. Same as the one we just did. So this time I'm giving you a gradient of 7 and it passes through the point 2, 10. So look at your notes that you just took on that last one and see if you can do this problem. Okay, let's see how you did. First step, plug in the point and the gradient. So y, remember this is xy, the y value is 10, equals the slope, 7, times the x value, which is 2, plus our b, which we don't know. Remember, the first step here is to find out what the y-intercept is. Now we have this equation. One variable, everything else is known. Let's finish her up. 10 equals 14 plus b. Subtract 14 from both sides. We get minus 4 equals b. So now we know that the y-intercept is this point, 0 minus 4. And we can use this minus 4 and plug it in step 2. We go back to using x's and y's here. So I have y equals mx, slope times x. Slope is 7, 7x, and then my intercept, my minus 4. Okay, our third technique involves having 2 points, one of which is the y-intercept. So this one's a little bit more involved, but nothing you can't handle, okay? So the first step is find the gradient. Okay? We have 2 points, so we can use our gradient formula. That is m equals y2 minus y1 over x2 minus x1. I'm going to label x1, y1, x2, y2, so I don't get confused. And let's plug that all in. y2, that's 2, minus y1 is negative 2, over x2, which is 3, minus x1, which is 0. Okay, interesting. So what this is going to be 2 plus 2, that's going to be 4 over 3. So that's our gradient. So we used these 2 points, we used our slope formula, and we found our gradient. So pause the video for a second, think if you can come up with what the next step is, because now you have the information to use one of the other techniques to quickly come up with the equation for this line. Okay, let's see how you did. Step 2 is plug in slope and y-intercept. We have that already. So plug in slope, which is also gradient, and the y-intercept. Okay, so that's pretty simple. We go y equals 4 over 3x, and we know our y-intercept from here is minus 2. So there's our equation. Okay, here's one for you to try. Same technique as we just did, the third technique. 2 points, one is the y-intercept. So there you have it. Pause the video, give it a shot. Okay, let's see how you did. Step 1 is find the slope. x1, y1, x2, y2. It's going to be y2, 1 minus y1, minus a negative, and then x2, 0 minus x1. Okay, so that's 0 minus 6. So now we get, this is actually going to be 2. This is 1 plus 1. 2 over negative 6. As a slope, we're going to write that as negative 1/3. That's our slope. Second step, plug that into the equation. Use our y-intercept here and our slope there, and we'll go y equals slope minus 1/3 x. Y-intercept is positive 1. And there's our equation. Now, I'd like to summarize a little bit. We did 3 techniques. There are other techniques that you can use. These techniques also feed each other. So you might get problems that don't look specifically set up to use one of these 3 techniques. But if you dig in and think about it, look at what you know, think about what you can figure out, I'm sure you can get there. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.